Honestly, muted. Never mind.
Was I muted the whole time? Whoops. Okay, so our first item is going to be talking about motors. There are two types of motors. There's brushed and brushless. So in brushed motors, the coils the coils rotate to generate power and a turning motion, and these can be connected directly to the battery. So this on the right. I think it's a sim motor. It has two wires. It just has a ground and a 5-volt, and it can be connected directly to the battery to supply a constant voltage, and it's always going to be running at the same voltage. So you can't really customize it or set it to go at any specific speed. And also it's much larger and clunkier than the brushless motor. So in brushless motors, a magnet with a variable frequency current generates the rotating field that turns the motor. So as you can see, brushless motors are better, or we use them more often in FRC because they allow you to supply a variable frequency current, which lets you control the speed and rotation of the motor. And in brushless motors, you cannot just directly connect it to a battery, or that may break it. It requires a motor controller in between to process the signal and send in the right amount of power. So we know about motor controllers, but there's something we have to talk about before we can move on. This is CAN. CAN stands for the Controller Area Network Bus, and it connects multiple devices. So in each of these is some kind of circuitry, PCB, which is connected to the CAN and for it to communicate with our robot brain, which is the RoboRio. It goes through these wires. And what the CAN bus does is it makes it much simpler to connect all these motor controllers to our RoboRio because we can link them to each other. So we call this daisy chaining. When we connect the motor controllers to each other, so that it only has to be connected to the RoboRio once, and the rest can be connected to each other. And this saves a lot of wiring difficulties on a robot. So each of these devices, these are all motor controllers here, but every device, including your gyro, is going to have a CAN ID. And they're all connected through a CAN bus wire to your RoboRio. You can configure the CAN ID of each motor controller with one of our UIs. There's the Phoenix tuner for Talons and the SparkMax Client for SparkMaxes. So all you have to do is connect these to a computer using a USB-C cable and set the CAN IDs. I believe you can also connect your computer to the RoboRio itself and set the CAN IDs through there for Talons. And this is important because when you're debugging, if one of the motors is not working or malfunctioning, it's very possible that the cause of that is a CAN bus problem or a problem with a single motor in the CAN bus, because even one broken device could cause any motor in there not to work, similar to a circuit in the series. So as you can see here, the green and yellow up here, these are the CAN bus wires. Okay, moving on to our first motor. This is the TalonFX motor controller. This is developed by Crossroad Electronics, CPRE, and this is the one that has a built-in motor controller. and the firmware for the motor. And usually motors have external controllers, and this is a really new design. The older one was the Talon SRX motor controller, and this would connect to the motor itself, and it's still used for other CTRU motors. But this one, the Falcon 500, comes with a motor controller, the TalonFX. So we use these a lot on our robots. It uses the Phoenix programming library, which is used for all Talon motors and controllers, and it's relatively easy to use. And one of the cool things about the TalonFX is it can actually play music, audio files. So here's some sample code for the TalonFX. So we have our own libraries for it, but what it's doing in there is stuff like this. For example, we can set a motor to have a % output of 0. This would just make it stop moving. This is an important function too. We can set a motor to, if we set its neutral mode, we can decide if we wanted to stop moving at 0 power or just continue moving until friction makes it stop. So for example, when we're driving the robot, we usually want it to be on brake mode so that we can better control it. The other option is coast, which we sometimes use for other functions. And we can also control the direction of the motor using set inverted. So there's clockwise or counterclockwise. And something really cool is instead of programming our own PID, we can just pass in the inputs to the motor controller, and it's going to store them inside slots. And you can set different slots if you want to use different PID values. And these two, integral zone and closed loop peak output, we might talk about them later. That's for more advanced like customization and PID tuning. So slots are just different sets of PIDF values for different actions. For example, we want a different PIDF set of values for going a specific distance and for turning to a specific angle, because these are different actions. Okay, moving on. There's the Phoenix software library. This is the library for the Talon SRX, the TalonFX, Victor SPX, CanCoder, Canifier, and Pigeon IMU. So the Phoenix tuner is the graphical interface that provides all the configuration, diagnostics, control, and plotting for our motor controllers. So as you can see here, you get a list of the devices connected to your CAN bus. So you see all these Talon SRXs, and you can set the ID and the name of each one of these devices. So this is really useful. For example, if we're debugging, we could set we could name the motors to their actual functions on the robot. And we have to make sure to set a different CAN ID for every device, because that's how it communicates. It needs a unique CAN ID. On here, we can also upgrade their firmware to the latest version, or whenever a new one comes out, we have to update the firmware. And the Phoenix software library also includes the Phoenix Diagnostic Server. You can install this onto the RoboRio for Phoenix Tuner and to perform HTTP API requests for diagnostic information. So that's also useful, and we use that sometimes. Okay. Thomas, you want to talk about SparkMaxes?
Okay, so SparkMaxes are a different type of motor controller, not developed by CTR. They're developed by Robotics, and they're used to control Neo motors. As you see on the right, that's a Neo motor. The library we use for SparkMax is just called SparkMax. It's also relatively easy to use, and it's pretty similar to the Phoenix library. But the motor controllers are also really fragile and like easy to break. We had a bunch of problems with them last year. So this year we're gonna try to like use them less and use more Falcons. And then there's also a client for SparkMax. It looks a bit nicer than the Phoenix one, but it's also similar. One advantage is that you can connect the SparkMax motor controllers directly to your computer and test the motors like by running them. So if you have to have a SparkMax and you connect it to your computer using USB-C, and you also have the motor and a battery, and then you can just test run your motor. And you can also test your robot by connecting your computer to the RoboRio, and it communicates to the motors through CAN. SparkMax Client will show all of your connected SparkMaxes as you see in the picture. There's only one there. And then you can see that it has the type of device, the CAN ID, and the firmware. So it's very useful in updating firmware and like reloading it, because often the firmware would get corrupted, so you have to reinstall it. Okay, Dylan's going to talk about the sensors.
All right, so for our sensors, so for our gyro, we use the Pigeon IMU by CTRE. We used to use the Spartan board, but now since I don't make them anymore, we use this. It's a 9-axis gyro, so it can use 9-axis. It needs temperature calibration if we want to get really accurate, and it's pretty simple to use. If you see in the code to the right, we can set all the we can instantiate it using CTRE's library, and that Pigeon ID in the ID constants, the first line there, that is the CAN ID. So a little bit ago we talked about CAN bus. So each device is referenced by their CAN ID, and that's how we communicate with them. So that's why it's important to set that on each device. And then again, the angle is pretty easy as well. We just call a function and we get all the different angles of the gyro. And that's it for gyro. All right, the Hall effect sensor. This detects when a magnet's nearby. We used this on the 2019 robot. We didn't use it for 2020, I believe. It's either on or off, and we used the digital input class. Here they use the interrupts, but we're probably are going to use just the .get method. So from the digital inputs. So this, if you look at the 2019 code, you'll see this interrupt handler, and it's a lot of things, source edges and interrupts when it triggers the interrupt and such. But we're probably just going to use the .get, which returns a Boolean, either a magnet's nearby or it's not. And that's how we can detect whether an elevator is all the way down or all the way up or anything like that. Next one are brake beams. We used this on our robot last season. It's similar to the Hall effect that uses the digital input class. It's a pretty generic class. It's a pretty simple little device in the top right there. You can see there's actually two parts of it. One just has a black and red wire. The other one has a yellow or whitish wire. And the one with only the black and white or black and red, that is an emitter. It will emit a IR beam, and then if we have to align them just right, and it will hit the IR receiver, which is connected to the RoboRio. And so if anything passes in front of that, such as the power cells in last season, we can detect that with the RoboRio and trigger some code. For example, if you look to the 2020 code, you'll see this is in the ball counter class. So in order to count the balls, we have to use that IR break beam. And you can see here, pretty generic. We just use the, so that IR ID, I believe that is a pin on the actual RoboRio itself. It's not the CAN bus. And then .get, that will just get the state of it either on or off, you know. It either receives the IR beam or doesn't. That's it for the break. Ultrasonic sensors. We didn't use these last season, I don't believe. We used these in 2019. And basically it has two parts, a transmitter and a receiver. So it will send out a ultrasonic sound, something we can't hear, and it will bounce off an object and it will bounce back into the receiver and that will hear it. And so you can see here that it uses the ultrasonic class, and we enable it, and then we use a method called getRange_millimeter. And the way this actually calculates the millimeter is it will calculate the time it takes to send it and receive it, and then we can calculate the distance using that. Although it's a little error prone, because if it's a slanted surface, it would bounce off the slant surface into another wall, which won't be the distance of slant surface. So it's a little finicky. Last year, I believe they used it when only for the dashboard. So it would only display on the dashboard and it's not used for internal state machines and stuff. The color sensor. This was a new thing that they added last season because they added the color wheel. And the color wheel, there was a bunch of sectors, each with a color in it. And this is by WarriorBorgs, I believe. And it's basically, it sends out, there's a little light on it. It's not mandatory, but it will read the color from it. It's basically a tiny little camera. It'll read the color from what it sees. It has to be pretty close. And it will send the RGB values back. Now, that's not inherently useful to us. So WarriorBorgs makes this class called the color matcher, where we give it possible options with discrete RGB values, like red. We want green to be this green, not, you know, green 100, red 0, blue 0, because it's probably not going to be exactly all green. So it picks the closest color. If we go to the next slide, we'll see an example of that from the code. It gets the detected color and then it matches it to the closest color it can find. And before this, we feed in a bunch of the values of expected colors. And we actually had to modify that a little bit because the printer that we printed out these color sectors for our testing, they weren't exactly the same as the vinyl. So we had to modify it a little bit to get to work with the printed ones until we got the vinyl on there. So, and then the proximity, it also has a little proximity sensor in it. And that's nice because it tells us whether it's reading just random colors from if it's far away from something or if it's actually reading color from the wheel. And then also confidence, which we display on the dashboard. And then the compressor. It's mainly handled through the PCM, which we went over, I think, in the FRC basics or the control systems talk. But it has a bunch of pins on it. A couple of them are for the compressor, and a few of them are for a pressure sensor and a bunch of valves for the pressure. And this allows us to, and then the PCM is pretty smart. It can set closed loop control, which will keep the PSI at a certain range. And yeah, it's pretty simple. We just instantiate it and set it. And we don't really need to think about it that much. And we use that pressure to activate actuators. And these actuators are controlled by the PCM by those, if you see on there, you can see like red and black like lines on it. And there's a bunch of them. That's how we control these solenoids that we use to power these actuators. And yeah, and it's connected via CAN bus, just like almost everything. And that's it for actuators. They're in and out. All right, so let's say they introduce a new sensor or we didn't cover something. And if you guys want to find out how we actually code using that, a lot of vendors, most vendors, probably all of them, publish Javadocs, which are it's a standardized thing which we might generate as well, but it's just a list of the methods and everything you need to code and a description of what everything does. It's really nice and you can find it really easily. Just type in the name of the device and then Javadocs, and you should be able to find it in the first few results. And I believe that's it. Does anyone want to add anything?
If you guys want to see previous examples of how we use like different motor controllers for like to control different parts of the robot, and you can also see like actuators, the compressor, like all of that stuff. If you want to see it in the real code base, you can go to our GitHub page and look at our previously released code. So I think we have everything up to our 2019 code release. So like feel free to check it out. It's github.com/team3256 if you guys want to check it out. Linus can probably show it also.
Also, it's a good time to talk about, make sure everyone has installed Git and IntelliJ and made an account on GitHub.
Oh yeah.
So I think some of our repositories are private, but we always make our previous season's repositories public. So you'll be able to see, for example, FRC Programming 2019. So this would be a public one that anyone can see. This contains all our code from last year or 2 years ago.
And a lot of the code for Tele-Op will be in subsystems in Tele-Op. That's the main bulk of where we program them.
Mm-hmm.
Does anyone have any questions about like the presentation or the GitHub?
All right. I also believe that this is the last day that we had planned for Tele-Op workshops. So I think from next week we're going to be starting the auto set of workshops. And the idea for these different workshops is so that you guys, we know you guys are interested in like software development, but the idea is that you guys will be able to like figure out which area you want to focus on and like really learn about, right? Because like that's super important. Like at competition, if there's a problem with a certain section, like we need people that like know everything there is about that section to debug it and like make sure it works. So this is like the end of the Tele-Op section. So hopefully you guys have like a pretty good idea of the different kinds of things you'll be doing. From next week onwards, we're going to be starting the auto section, which includes like the math behind autos, as well as a couple of our implementations of auto. So if you guys are like more interested in like the math side of programming, or like the physics side, then that might be something for you. And then I think in the weeks after that, we're going to be going into the vision side, which also involves a lot of math. But that's more if you guys are interested in like computer vision, like machine learning, that kind of thing. So hopefully you guys have like a pretty good idea of like what kind of things different subteams do. And Yeah, I know, like, there's a lot of information, especially since you guys aren't in the room and we can't, like, show you how, like, each part of the, like, how everything interacts with one another. So, like, feel free to ask us any questions. And if you want us to, like, show you guys, like, an example or something, we could probably find videos online of, like, different parts being tested, like the SparkMax Client, stuff like that. And feel free to do your own research also. Do any of you guys have anything you want to add? Thomas, Linus, Dylan?
Nope, nothing in particular.
Yeah. All right. So yeah, we know this workshop was a little more of a shorter one because we covered most of the Tele-Op stuff, all the state machines that we use, in our previous workshop. But yeah, this workshop was mainly to talk about like the specific Tele-Op functions we use to actually get values from the gyro, like actually use like the motors, things like that. So hopefully you guys have a better idea of that stuff now. Do we already show them Tele-Op Updater last time with the updating joystick values? We briefly went over that, right?
I think so, yeah.
Okay. And Linus can also go to our code from last year since he's on our GitHub, and I kind of show you guys how Tele-Op Updater uses information from the different subsystem state machines. And based on the joystick input, it changes the states that we want the robot to run on. So yeah. We have an Xbox listener base that listens for changes in the Xbox controllers commands, and based on the buttons that are pressed, we can update the different states.
Oh, I think we did control schemes this year.
Yeah. You're on 2019, right? Yeah. We did event based.
That one was different.
Yeah. That one was pretty interesting, actually. So in 2019, we tried something new where instead of like changing the states, like we had different events that we were listening for, and like when a certain event happened on the Xbox controller, like instead of changing states, we would like just update the command. I think eventually for 2019, we ended up using kind of like a mix between the two systems. But yeah, these are like more things that we're going to explore in hopefully this season and future seasons to see like which one is the easiest for us as well as the drivers to use, which one works more reliably. If you guys have any questions or if you want us to like show you a part of like the like code from previous years, like feel free to stick around. Otherwise, I think you guys are free to go. Yeah, today's workshop was a little bit shorter, but I think the next couple workshops on auto are going to be pretty long because there's a lot of information to cover. So yeah, so feel free to go. Thank you guys for coming. Unless you guys like Linus or Thomas or Dylan have something else to add.
Thank you.
Yeah, thanks.
Good job, guy. Thank you.
Thanks, Mr. Deep.
So I am
Roll on.
last workshop.
Long time no see, no talk.
Yeah, it's been a while.
Oh yeah, I jumped to cat.
All right.
Bye.
Did one of you guys have a question? Bye. I think somebody was saying something. You missed a workshop?
So
Or?
I missed last workshop, the workshop a couple days ago. And so can I access those? I think somebody posted about the workshops on YouTube.
Yeah, I'll send a link in the chat.
Those.
Yeah, I can send a link in the chat to make it easier. Yeah, give me a second. So this was the workshop from last year. This is the workshop from last time. I don't know if you can see it. I think I put it in the chat.
Yes, I can see now. Thank you.
Yeah. And feel free to ask us if any of you guys have any questions about anything. Yeah.
also about the Git and IntelliJ setup. There's nothing in particular. You can play around with it a little bit, find out how things work. That's probably going to help you in the year. But otherwise, nothing specifically.
I had a question for Rohan.
Mhm.
I was looking through the code, and you guys have your own library for.
Are you talking about WarriorLib?
Yes.
Yeah, so that's something that one of our alumni made a couple years ago. Basically, first has a rule where any code we want to reuse from year to year, like any like auto code or things like that, we have to make public on our GitHub. So like that's why a lot of teams use like they make their code base public so that they can reuse parts of it for the next year. So like in the interest of keeping everything that we want to reuse in the same place, one of our alumni made WarriorLib. So we just update that yearly and we import it at the beginning of each season. So it's kind of a repo for all of our like all of the classes that we know we're going to be using from year to year. So like we have certain wrapper classes for different commands, like a couple of the classes in the Phoenix library are a little like hard to use, or like they require like a lot of like boilerplate stuff, and that's all being handled in WarriorLib. So we can just like initialize a new Talon, and in WarriorLib, when we call the method of our wrapper class, so like not the actual Phoenix class, it'll handle all of the initialization for us. So we can just pass in 2 parameters instead of like calling in 15 methods. So basically, to answer your question, yeah, so we have our own library called WarriorLib that we use season to season, and we update it each season. Did that kind of answer your question? Or
Yeah. How do you update that library though?
so it's basically its own project that like I think we're building it right now using let me pull it up actually. Are you talking about like how we like push to it, or how it like integrates with our current system?
Like, how do you expand it with?
It's just a GitHub repo. So like we just like it's the same as our like normal code. We just push to it. We make a new like Jetpack release, and we add it to our code base. There's nothing like super special about it.
Oh, okay. Thanks.
Yeah.
I had a question. So we can only work on one part of the software thing. So there's a lot of different sub things in software. We have to specialize in one.
Yeah. Linus, you want to talk about this?
I think usually at the start of the year we would have like different sub projects. For example, like people working on the color spinner last year, or people working on the feeder. And in the end, it usually starts off with like the Tele-Op stuff. The auto probably won't change much from year to year. Because we have the libraries for that done. So I think it's always good to get a big picture of how everything works and be able to at least use all the hardware and help any teams that need help with like prototyping or using the prototyping board, stuff like that. And if you want, you can also like get into vision and learn some machine learning, vision detection, like Thomas has done.
Cool.
I mean, basically, if you start in a subsystem, you don't have to stay in it for the whole year.
Okay. Thank you. Bye-bye.
Any
Thank
other
you.
questions? All right. Bye.
Thanks.
Hey, nice job today, guys. It's pretty good.
Mm.
I think next week's presentations are we should probably start them on weekends because I think some of the auto stuff might get a little complicated. So we need to figure out like an easy way to explain it, how we want to break it down, I think.
Can we show the 254 presentation?
Yeah, we just spend our time showing them their that'd be pretty helpful actually.
You just
But
replace it
The
with
presentation.
WB.
we just replace it with our presentation. We just say what they say. I was thinking of like the first one would just be like an overview of like the different auto methods and then like just kind of the math behind each one. And the second one we could get into like our actual implementation of pure pursuit based on like the white paper or whatever.
Yeah.
What do you think? I think that'll make because like ultimately like I don't really want them to think that like the way we're doing auto is like the best or most optimal way because I mean they should probably like make something new in a couple years. You know, like when 254 makes like the new cool thing, and we should also do that. You know, like they have their Oris Health mentors, their Google Robotics mentors that are going to create some new algorithms.
Wait, so next week is auto, right?
Yeah,
Okay.
I think auto's 2 or 3 sessions. I'm not sure. And then vision. Vision's gonna be fun. I think.
Mm-hmm.
Really enjoy it. All right. Well, I'm gonna head out.
Okay.
Bye.
See you guys.
All right. Bye.